Hello my dear students. So this video is about the next chapter of a Karnataka CET of a previous year questions as we were discussing, okay, where if you have gone through my previous video, there we have completed solid solution, okay, and followed by recently we have completed chemical kinetics, where even the NEET questions been discussed in all the three chapters, okay. If you have not gone through the video, please check my previous video so that you can get some useful tricks and the simple way to solve everything being discussed over. It is requested to see the video completely so that you will get an idea what is the weightage of the each chapter, okay, how the questions will appear, on which concept the questions will appear. So each and every important thing you will going to understand by the video. At the end of the video you can get it, okay. And similarly, in one of my video I have given weightage of each chapter, like for example in the structure of atom, how many questions will appear. Since from 2015 to and 2019 I have analyzed each paper, okay. So you can go through that one, through which you can get the weightage of each chapter, okay. Please go through all the videos whichever I have uploaded over there, okay, so that it will be very useful. So similarly, please go through the complete video. At the end of the video we'll get some idea and the tricks, okay, and how to solve each and every questions when the concept been explained in detail. So in that belief, let us move to the first question, and here you could see. So the topic that I have taken is structure of atom and the periodicity of elements, that is the classification of elements and periodicity in properties, okay. Both are the first PU chapters I have taken, okay. Here the weightage of the chapter is like that, so not much weightage you could see, but yet since a simple questions will appear from this, you are not supposed to neglect as well, okay. So from the structure of atom, there is a chance of appearing one question, okay. Similarly, from the periodicity of elements, there is a chance of appearing of one or two questions. So overall, I could say the weightage is around 2 to 3 questions, where 3 questions is very maximum, okay. Around 2 questions, one is from the structure of atom and one is from the periodicity of elements, okay. So this is what the weightage. So when I go on solving, you will get an idea how many questions been asked in each year, okay. So now this is the first year 2015 questions I have taken. So the number of questions already I have mentioned here is 2. Okay, that is one question is from the structure of atom and the one question is from the periodicity of elements. So let us go through the first question over here. So the question is like, the 2 electrons have the following set of quantum numbers, okay. That is p electron with a quantum number 3, 2, minus 2, plus 2, q with a quantum number 3, 0, 0, plus 2, plus half, okay. So which of the following statement is true? That is, P and Q have a same energy, P has a greater energy than Q, P has a lesser energy than Q, P and Q represents the same electron, okay. So this question you can solve when you have an idea regarding the quantum numbers, okay. When you have an idea regarding the quantum numbers, you can solve very easily. At the same time, there comes a rule called N plus L rule, okay. So N plus L rule will represent N plus L rule will give which the energy level of each orbital, okay, where N is nothing but a principal quantum number, L is nothing but a orbital quantum number. So before going to this, at least you should have some idea regarding the quantum number, okay. So there are 4 quantum number as we all know, that is principal quantum number, okay, azimuthal or orbital quantum number, the next one is magnetic quantum number, and the next one is spin quantum number, okay. No need to worry about the spin quantum number. So when we have a pair of electrons, so one will be like with a clockwise direction or the rotation, one will be with the anti-clock. So I could write here spin as plus or minus half, okay. So when N comes, it is quite simple. So if N value equal to 1 means it is like a first orbital, or the K shell will going to say, okay, K shell or the first orbital, okay. Similarly, N value goes on increasing. L value, this is very important, okay. If L equal to 0 means, okay, you have to remember this value. L equal to 0 means it is s orbital. Okay, if L equal to 1 means it is p orbital. If L equal to 2 means it is d orbital. L equal to 3 means it is f orbital. So do remember, okay, do remember. So L equal to 0 means s, L equal to 1 means p, similarly d, f. Okay, similarly m value here. Okay, the m value for the for the s orbital is 0. This you have to remember. Means the s orbital don't have any any suborbitals over here. Okay, so the s orbital has the magnetic quantum number m, that is 0. Okay, for the p orbital we have the magnetic quantum number, that is, we know that p orbital has a 3 suborbital, px, py, pz. So it is like -1, 0, +1. Okay, for the d orbital, how many suborbital we have? 5 orbitals. So we have -2, okay, -1, 0, +1, +2. Okay, this you have to remember. Okay, and for a f orbital it is -3, -2, -1, 0, +1, +2, +3. How many? 7 suborbital. So f orbital has a 7 suborbital. So you have to remember all these values, students, so that it will get very easily. Okay, yes. Now let us move to the question. Here what they have given, p value 3, 2, -2, +2. Sorry, +half. Okay, so always if they have given in the order means you should understand the first will be n value. Okay, and next will be L value, this will be m value, and this will be s value. Okay, this is how the arrangement will be given. N equal to 3. So for p let us write n equal to 3. Yes, fine. L equal to 2 means which orbital? I have mentioned here. L equal to 2. L equal to 2 means which orbital? D orbital. So it is 3d orbital. Okay, and I have mentioned here -2. Okay, so -2 means again it comes here only. -2, it's a d orbital. Okay, any one suborbital you will going to get over here. Okay, so this is for what? +half means there is a presence of a 1 electron. Okay, so this is a p orbital, means the orbital for the p electron. Okay, similarly let us find out for the q. So q, we have a n value 3, let us write 3. We have a L value 0. As I told, L equal to 0 means it is a s orbital, so it is a 3s. M is 0, so it is a 3s, +half means 1 electron is there. Okay, so now what we got? We got which orbital, that p and q electrons are present. Okay, so what is the question? What is the option they have given? P and q have a same energy? No. So if you get to know like 3 and 3, both are like a third orbital, you could say. So can I say both have the same energy? No. How will going to get to know that whether they have a same energy or not, whether one have a more energy or one have a less energy? It is by the n plus L rule. Okay, n plus L rule will give which has the highest energy, which has the lowest energy. Okay, so if I apply n plus L rule for this, just observe n plus L rule. Okay, what is the n value for this 3D? It is 3. It is given there. Okay, what is the L value for the d orbital? It is 2, that I have told here. Okay, 2. So how much value you are going to get? 5. Okay, similarly come to the q electron, that consists of a 3s orbital. If I apply the n plus L rule over here, okay, so n is common 3. For the s orbital, L value is 0, so it is 0. So what is the value you got? 3. Means by the n plus L rule I could find which one is having the highest energy, which is having the lowest energy. The n plus L value, if it comes lower than that we are comparing with another electron, so it will be having a lower energy. So can I say by these values, okay, the 3s orbital means it's a lower energy level than the 3d orbital. So can I say q has a less energy than the p orbital. Or let us take the options over here. P and Q have a same energy. No, since we have got a n plus L value different. P has greater energy than Q. Exactly. So because n plus L value we got greater phi value, okay, P has greater energy than Q. Okay, so similarly P has lesser energy than Q. No, that will not come. And P and Q represent the same electron. No, okay, since different orbitals, okay, it will going to represent a different electron. So it is option 2 which is correct. Okay, so no need to go through all these things. If you get to know this P is 3d orbital, Q is 3s orbital, okay, you can represent. We know that 3s orbital will be filled first, followed by the 3d orbital. So by the Aufbau principle, I could say the filling up of electron takes place in the increasing order of energy level. First the lower energy will be filled, followed by the higher energy. So in that way I could say 3s is the lower energy level and 3d is the higher energy level. So that option 2 is the correct one. So students, I have given a 3 way of solving this one. Okay, so for everything you should know how to write the quantum numbers, means how to write the orbitals by using the quantum numbers. Then it will become very easy. So this is the first question of 2015, and this question is from where? From the structure of atom. Okay, so let us move to the next question over here. So the question is that for one of the element, various successive ionization enthalpy, that is in kilojoules per mole, is given. Okay, so we should tell the element is which one. Okay, so element is which one? Quite simple. See here, I hope you have understood the question. Okay, try to solve, okay, along with me, so that it will be you will get it easy. Okay, each concept is very important while solving. So first see here in the column what they have given here, it's a ionization energy. Okay, so this is the first, second, third, fourth, fifth. So these are the first ionization energy, second ionization energy, third, fourth, fifth ionization energy. What do you mean by this? So we know that what is ionization energy? It is nothing but the amount of energy required to remove the outermost electron. Okay, so if I want to remove an electron from a stable atom, okay, if the size is very small, so that the outermost electron is strongly held with the nucleus. So in that case, I can't easily remove that outermost electron. So for that, I need to provide a more energy. Agree? Okay, so like that, what happens? So in first, second, third, fourth, fifth represent that the energy required to remove the first outermost electron, the energy required to remove the second outermost electron, and the third outermost, fourth, fifth, like that it is been given. Okay, so we need to tell which element is, whether it's a silicon, whether it's a phosphorus, whether it's a aluminium or magnesium. So how we're going to get? So if I follow the order here, if I get to know the order, just observe. To remove the electron, the first electron, first in the sense the outermost electron, okay, how much energy been spent? 577.5 kilojoules per mole. Okay, fine. When it comes to second electron, okay, when I need to remove the second electron from the same element, okay, so you could observe there is a sudden increase, a little bit of more increase in the ionization energy. That means I need to spend more energy to remove the second electron than the first electron. Okay, similarly come to the third electron. Okay, for the third electron, I could find 1810 is for the second, means for the third electron, a double of the energy I need to spend to remove. Right? Okay. So now similarly for the fourth and the fifth electron, for a third to fourth electron, you could see here. Okay. So there is a triple or the 4 times the energy we need to spend to remove that fourth electron, where between the fourth and fifth not much difference over there. Okay. So just observe. These all things depends on what? These all things depends on the electronic configuration of each element, I could say. Okay. What is the atomic number of silicon? I'm going to write here. What is the atomic number of silicon? It is 14. So can I write 1s2, 2s2, okay, 2p, 6, 3s2, okay, 3p2. This is what, right? So 10, 12, 14. Yeah, very good. Then for P it is 15, like 1s2, 2s2, 2p6, 3s2, 3p3. Okay, now let us write for the aluminium, that is atomic number 13, 1s2, 2s2, 2p6, 3s2, sorry, 1s2, yeah, 12, 3s2, 3p1 over here. Okay, yes, it is correct, 3p1. Similarly, when it comes to magnesium, 12, 1s2, 2s2, 2p6, 3s2. Okay, now let us observe the first ionization energy here. So when I compare silicon phosphorus, okay, here we could have 3s2 3p2 orbital, 3s2 3p3 orbital. Okay, so it is very difficult to remove this electron. Why? We know that exactly half filled orbital are as stable as the completely filled orbital. Agree? Okay, 3p3 is exactly half filled orbital. Okay, so I need to spend more energy than expected to remove the electron from here. Okay, so that I am not going to consider here. Okay, and then consider silicon. Okay, so silicon, when it comes, I can easily remove the electron from the p orbital because it is not exactly half filled, neither it is a completely filled, so I can remove this electron. Okay, at the same time, when I remove the one electron, the remaining here one is like a 3p1. Okay, so 3p1 electron, I can remove this electron as well very easily because it is not neitherly full nor half filled. Okay, so here what they have mentioned is, so sudden little increase, double of the value. Okay, but here not much energy is required, so even I can't consider silicon and the phosphorus. Okay, now it comes to aluminium and the magnesium. Okay, so let us go through which I could say, for example, here only. Okay, let us go through here. So 3s2 is a stable orbital, I agree. Okay, so I can remove this electron, like a little bit of energy is needed to remove this electron. Yes, so more ionization energy will be there for the first. Okay, so when I remove this one electron, okay, so 3s1 electron is left over. Okay, so not much energy is needed to remove this electron, because already from the 3s2 I have removed one electron by spending a more energy. Okay, so now it is already like a unstable. So when second ionization energy is not that much high, it will be high but not this much of gap of energy is required. Okay, so the magnesium will also not come. So the only thing is that aluminium. How? So you could observe here we have a 3s2 3p1. Dear students, it is 3p1. Okay, now so I can remove this 3p1 electron very easily because it is only one electron is present in a p orbital. I can remove it very easily. Okay, that is fine. Okay, so the value 577.5 is somewhere matching. Okay, now when I remove this 3p electron, the second ionization energy I had to remove from where? From the 3s orbital, that is completely filled orbital. Okay, so I need to spend more energy to remove this electron than the first. Double of energy I need to apply. Okay, so it is fine. So 3s1 I can remove. Okay, now come to the third orbital. So here also what I could say, from 1810 to 2750, sudden double of the energy, it is because the size shrinks. Okay, when the size shrinks, the outermost electron here will be held closely. Okay, so even the third ionization energy is also high, but you could observe the fourth ionization energy is very much high compared to third. Why? Here I need to remove electron from the stable configuration, from the completely filled orbital. So since it is a stable, it will not going to give an electron, right? So it will going to, like, we need to spend more energy to remove this electron. So there is a sudden increase, a much increase in the ionization energy of a fourth electron. Okay, so it's an aluminium, which is the correct one. Okay, so which is the answer? The answer for the second question is aluminium. Okay, if you know the idea of ionization energy and so the first, second, third, so you can answer it very easily, even though you have to remember the atomic number. Okay, so this question was from the periodicity in elements from the same year. Okay, yes, I hope it is clear. If you have not gone through, please comment me in the comment box so that I can solve little more. I can explain you in a better way. Okay, so next one is from the year 2016. So again, I have mentioned here the number of questions are like 2 questions. So one is from the structure of atom and one is from the periodicity. Okay, so such a simple question. Again, you could observe this question is from where? From the quantum number. Yes, so consider the following set of quantum numbers. So which of the below setting is not permissible arrangement of an electron in an atom? Okay, so you could see here what they have done. They have given 4 examples. Okay, 4 orbital quantum numbers they have given. Okay, if I try to write the orbital by using this quantum number, we can get one idea. Okay, so that which is like a correct quantum number is given or not, we can find out. Okay, for this, the first question I discussed, like what is the n value, what is the l value for the s orbital, those all points you have to remember. Okay, so it takes hardly 5 minutes to practice that one. Please do remember all the values that I have given here. Now let us go through here. N is 4. Let us write 4. Okay, L value 0 means which orbital? It is s orbital. So it is a 4s orbital. For L equal to 0, since it is a s orbital, its m value equal to 0. So this arrangement is correct. Spin quantum number is -12. So that is 1 electron present over here. So this is how you need to write. Okay, now come to the second option. 5, quantum number 5, write the 5 over here. If L value is 3 means which orbital? I am writing here L equal to 0 means s orbital, L equal to 1 means p orbital, L equal to 2 means it is d orbital, L equal to 3 means it is f orbital. Okay, so 5, L equal to 3 means it is a f orbital, so it is 5f. Okay, so this 5f, 3 is there means maximum -3 like a +3 it includes, that is magnetic quantum number, so that includes 0 as well, so this is correct. So half, 1 electron will be there. Okay, let us come to the third option. So quantum number 3 here, write 3. L is 2 means it is d orbital, it is 3d. Okay, for the d orbital, the maximum value or the value that you can get for the magnetic quantum number is -2. -2, -1, 0, +1, +2. Okay, so here we have a -2. Yes, it is an orbital, like magnetic quantum number for the d orbital. So 1 electron, 1 electron. Okay, let us come to the last option. So we have a 3, L equal to 2 means it is a d orbital. Okay, m equal to -3 are that telling. But for the d orbital, we have a m value -2. Okay, -1, 0, +1, +2. Okay, so this is what the orbital value, each suborbital have the values. Okay, maximum 5 orbitals, we have a 5 values, but here they are mentioning it as a -3. So -3 will come where? For the f orbital, but here the -3 is not there for the d orbital. So this arrangement is not permissible arrangement for the electron. Okay, so option 4, that is the correct option, which is not a correct quantum number been given for the 3d orbital. Okay, so this is how you need to find out. I hope it is clear. Okay, so if you know the quantum number values, it is very easy to solve such type of questions. Okay, so let us move to the next question, that is the increasing order of a bond order of, okay, I hope you can see the increasing order of a bond order of oxygen, okay, and O2 plus, O2 minus and O2 minus 2 is given. Means the increasing order we have to arrange among all these oxygen ions, okay, according to its bond order. Okay, so there is a different way to solve the bond order for a given compound by the molecular orbital theory. I hope you remember. Okay, so by the molecular orbital theory we can solve it, but since we have a less time here, so we can't write the bond molecule like a MOT diagram for the oxygen, okay, and we can't calculate the bond order by putting a formula. So for that reason there is a simple way. So this I have seen and I have practiced, and in that way I am explaining you people. Just observe here. Let us write 14 here. Okay, so below this one like 15, 16, 17, 18. Okay, so similarly above this 13, okay, 12, 11, 10. Okay, so let us consider this 14 as the center one. So corresponding to 14 it is 3. Okay, and below 15 it is reduce 0.5, so it is 2.5. For 16 it is 2.0, for 17 it is 1.5, for 18 it is 1.0. okay, similarly here for 13 it is 2.5, okay, for 12 it is 2.0, for 11 it is 1.5, for 10 it is 1.0. What it is here, this 10, 11, 12, 13, 14 are nothing but electrons, total electrons. So these numbers are nothing but the bond order. Okay, so let us apply this rule. For example, let us take a oxygen. Okay, so oxygen is a molecule they have given here. So two oxygen means one oxygen has atomic number 8. So 8 plus 8, how much we are going to get? 16. Okay, total electrons present in oxygen are 16. Okay, I hope you understand how to find out. So 16 means corresponding to 16, what is the bond order? We have a 2. Let us write 2 here. Okay, so what is next? O2 plus. Okay, so means O2 plus means among 16 electron, 1 electron is removed. So how much it becomes? It is 15. Okay, corresponding to 15 we have a bond order 2.5. Okay, so next comes to the O2 minus. O2 minus means, so 16 electron are there, minus means 1 electron is added, so it becomes what? 17. So for the 17 corresponding we have 1.5. okay, bond order. So the last one is O2 minus 2. okay, so 16 minus 2 means plus 2 add, we are going to get 18. So 18 electrons means we have a 1.0. So this is how you can find out the bond order. So the increasing order of a bond order means, increasing means what? From small number to high number. So how increasing? Which has the lowest value? It is O2 minus 2. okay, so next increasing, okay, step up like that. So next we have O2 minus. So next we have O2 followed by we have O2 plus. This is the increasing order. Okay, so which is the option correct according to this? O2 minus 2 is there, O2 minus there, okay, O2 is there, O2 plus. So the option 4 is the correct one. Okay, do follow this trick. Okay, this I have seen and have practiced, on that way I am telling. Okay, so by using that one you can find out the border and you can arrange them accordingly. Okay, so this is based on a bond order. So next move to the question, that is the energy of an electron in the nth orbit, okay, of a hydrogen atom is. So to find out what is that energy of an electron, see, an electron to jump from one orbit to another orbit, okay, the energy is lost or gained over there. Okay, so that can be found out especially for the nth orbit of a hydrogen atom. Okay, so the standard formula we have that En is equal to minus 13.6 by N square electron volt. Okay, n value represent the which orbit it is jumping. If n equal to 1 orbit, this is a, we're going to write n value 1. So its value will be minus 13.6 like that. N equal to 2 means I'm going to substitute 2 here. To 2 square means 4 will become, okay. So 13.6 divided by 4, okay, around 8 point something you're going to get like that. So this is a standard formula we have. Okay, so the question is simple. The energy of an electron in the nth orbit of a hydrogen atom. Nth orbit means we have n value itself. That is the direct formula we need to apply, minus 13.6 divided by n square electron volt. So which is the option correct? That is minus 13.6 electron volt. Okay, divided by n square. So this is for the hydrogen atom where the electron jump from one orbit to another orbit. Okay, n value we need to find out. Clear? Yes. Okay, so this is the fifth question of 2016. Okay, and the next question is from 2017. So the number of questions here been asked around again 2. Okay, one question is from the structure of atom and one question is from the periodicity. Again, you could observe the question is based on a quantum number. Okay, the correct set of quantum number for the unpaired electron of a chlorine atom. Okay, the correct set of quantum number for the unpaired electron of a chlorine atom. Particularly, they have mentioned here as a chlorine atom. Okay, so for that chlorine. Okay, so what is the atomic number of chlorine? We have a 17. Let us write the configuration. 1s2, 2s2, 2p6, okay, 3s2, 3px, 3py, 3pz. I am writing the suborbital, okay, so 3p, how much it is? 6, like 8, 10, 12 over. So here 2, 2, 1. Agree? 3p5. Instead of writing 3p5 directly, okay, I'm dividing, I'm substituting or based on the orbitals over here. Why? It is because here they have asked the correct set of a quantum number for the unpaired electron in the chlorine atom. So which is the unpaired electron we have, students, here? This is an unpaired electron. Okay, so this is an unpaired electron we have here. Okay, for this we need to write the quantum numbers. Okay, how we are going to write the quantum numbers? So let us take 3pz1. Okay, so by this I can find out all the quantum number values. How? It is z. Okay, what is the n value? 3. So write 3. Okay, since we have a p orbital, we know the L value for the p orbital. How much? It is 1. Okay, now what is the magnetic quantum number? So as I told, L1 means minus 1, 0, plus 1. These are the magnetic quantum number. Since it is a z orbital, we have a plus 1. This is px, py, pz. So for m value it is pz. Okay, m value here for z means we're going to write a plus 1. Okay, plus 1. So since odd electron is there, either it should be a plus half or minus half. So plus or minus half. Okay, so this is how you need to find out the quantum numbers. Okay, when the orbital is given. So which is matching with the options? 3 we have. Okay, 1 we have. 1 we have, plus or minus half we have. So option C is the correct one. So here the A and B option you can give it off. Why? Initially only we have 2 over here. No, orbital principal quantum number 2 means here we are seeing it as a 3. So no need to consider these two options. Only left is between the C and D. Okay. So here we have a 0. L equal to 0 means we're going to get what? 3s orbital. But we have a 3p orbital. So it is option C which is correct. Okay. Yes. Such a simple question you could observe. One question will be like a compulsory from the quantum. Yes, dear students. So the next question is that the electronegativities of a carbon, nitrogen, silicon and the phosphorus are in the order of. Okay, they have arranged the electronegativity of all the following 4. Okay, so in the what I could say, phosphorus less than silicon, okay, followed by nitrogen, carbon, in that way. Okay, so from lower to higher value they have arranged. Okay, so now we could have some idea regarding the electronegativity. What do you mean by that? It is the capacity to attract the electron towards itself. Okay, if the size is small, if the size of an atom is small, so that the outermost electron are strongly held with the nucleus, means more the attraction will be there between the nucleus and the outermost electron, so it will going to attract the electron, so electronegativity property will be high. As the size increases, what happens? The distance between the nucleus and the outermost electron decreases. So that, distance increases, the attraction what happens? Decreases. Why? It is because since the distance is more, this outermost electron will not come under the attraction force of a nucleus. So that they are left free, can be removed very easily. Okay, so we have an idea that along a period, what happens to the electronegativity property? Okay, it increases. The electronegativity property increases. So down the group, what happens? The electronegativity property decreases. Okay, the electronegativity property decreases. So these 2 points are very important. Okay, so why? Because they have given a carbon, nitrogen, silicon in the phosphorus. So carbon followed by the nitrogen. Agree? Okay, carbon followed by the nitrogen according to the arrangement in a periodic table. Okay, so silicon comes under a carbon family and phosphorus comes under a nitrogen family. Okay, now along a period, as I told, the electronegativity property increases. Means what? Carbon will be having the less electronegativity than the nitrogen. Agree? Yes. Now, when I compare silicon and the phosphorus, okay, this is also along a period. If I consider, silicon will be having a less electronegativity than phosphorus. It is correct. Okay, now between the nitrogen and phosphorus, which will be having the less electronegativity, it is the phosphorus will be having a less. Why? As we know, the down the group electronegativity property decreases. So phosphorus will be having a less electronegativity than the nitrogen. Okay, similarly when it comes to silicon and carbon, which will be having the less? The silicon. Okay, so this is how we need to arrange. Now if I observe all the 4 options, so when I see the options they have given, okay, here I could say among all silicon is having the less electronegativity, followed by what? Phosphorus. Okay, and compared to phosphorus and carbon, phosphorus will be having a less electronegativity than carbon. Okay, compared to carbon and nitrogen, carbon will be having a less electronegativity than nitrogen. So among all, which will be having a more electronegativity property, it is a nitrogen. Okay, so the answer is option C, which is correct. So make an arrangement like this. Okay, try to compare and try to answer, you will get to know. So you should know that what happens, the trends, if you know, it is very easy to answer such type of questions. Okay, so this is what